Okay, today's objective is the student will be able to write equations into variables. There are two standards that we're working with today, 6EE5 and 6EE8. Some vocabulary that we'll need to know for the lesson. Well, what do we mean by an equation into variables? Well, an equation into variables represents two quantities that change in relation to one another. A solution of an equation into variables is an ordered pair that makes the equation true. So we're going to be using ordered pairs to identify whether or not those values are solutions to an equation with two variables. Here's our first example. We're given an equation, right? Here's the equation. Y is equal to 2 times a number x. We're given an ordered pair. Remember that an ordered pair is an x value and a y value. So 3 represents our value for x. 6 represents our value for y. In order to identify if an ordered pair is a solution of the equation, we have to replace the variables in that equation with the numbers given from the ordered pair. So I'm going to replace y with 6. I'm going to replace x with 3. And I want to see, is that an equation that's true? Is 6 equal to 6? And the answer to that is yes. So that means that the ordered pair 3, 6 is a solution of this equation, because the x value of 3 and the y value of 6, when we replace the variables in the equation with those numbers, we get an equation that's true. Let's try the next example. Here's our equation. It says y is equal to 4 times the number x minus 3. We're given the ordered pair 4, 12. So 4 is our x value, 12 is our y value. All right, so I want to replace x with 4, y with 12. So I get 12 is equal to 4 times, and I'm going to replace x with 4, minus 3. Is 12 equal to, 4 times 4 is 16. Is 12 equal to 16 minus 3? Is 12 equal to 13? The answer to that is no, which means 4, 12, that ordered pair is not a solution of this equation in two variables. When we replace x with 4 and I replace y with 12, we do not get an equation that is true. All right. When we have an equation in two variables, each of those variables represents either an independent or a dependent variable. Well, what does that mean? Well, let's read. You can use equations into variables to represent situations involving two related quantities. The variable representing the quantity that can change freely is the independent variable. The other variable is called the dependent variable because its value depends on the independent variable. Simply put, your input value, right? Your input value is your independent variable. Your output value is your dependent variable, right? Your input value is your independent variable. Your output value is your dependent variable. And that is because the output depends on the input. All right? So let's take a look at an example. It says the equation y is equal to 128 minus 8 times the number x gives the amount y in fluid ounces of milk remaining in a gallon jug after you pour x cups. Identify the independent and dependent variables. Well, like I said before, your x value, right? Your x value or your input variable is your independent variable. Well, it says x represents the amount of cups. Well, if x is your input variable, the independent variable, right? The independent variable are your cups. Well, what is your dependent variable then? Your dependent variable, right, is your output, your y value, and your output is the amount y in fluid ounces. So your dependent variable are your fluid ounces remaining. Your fluid ounces remaining. All right, that is your dependent variable, because the fluid ounces that remain in a gallon of milk depends on how many cups you pour out. All right, let's look at the part B. How much milk remains in the jug after you pour out 10 cups? Well, we're told to use the equation to find the value of y when x is 10. X is your independent variable. That is your input. So I take my equation, y is equal to 128 minus 8 times x, and we're going to replace x with 10. So your next equation is going to look like this. 128 minus, I'll just cheat a little bit, 8 times 10. We replace the variable x with 10 in the original equation. And then we solve. Y is equal to 128 minus 8 times 10 is 80. And what's 128 minus 80? Y is equal to 48. And those 48 represents the ounces remaining. All right? Okay, now the on your own problems, I'd say, stop the video, try these problems on your own. Okay, you stop the video now. All right, I'm going to pick up in a minute and do the solutions. All right, so let's take a look at example 1. Tell whether the ordered pair is a solution of the equation or not. If you remember, we take our ordered pair, 2 and 21. 2 is our input or our x value, 21 is our output. So I'm going to replace y with 21. Well, first I always like for you to write the equation. So y is equal to 7x. That's the equation. I'm going to take y, replace it with 21. Is that equal to 7 times, replace x with 2? Is 21 equal to 7 times 2, which is 14? The answer to that is no. Which means 2 and 21 is not a solution of that equation. All right, let's try problem 2. Write the equation. Y is equal to 5x plus 1, right? I write my equation. I want to see, is the given ordered pair a solution of that equation? 3 is my x value, 16 is my y value, because every ordered pair, right, is an x value and a y value. So I'm going to replace y with 16. I'm going to replace x with 3. And is 16 equal to, 5 times 3 is 15, is 16 equal to 15 plus 1? Right? 16 is equal to 16. So the answer to that would be yes. Okay? Problem 3. The equation y is equal to 10 times a number plus 25 gives you the amount y in dollars in your savings after x weeks. Okay, part A, identify the independent and dependent variables. So for part A, my independent variable is always going to be my input value. X represents what? Weeks. So my independent variable are going to be my weeks. My dependent variable, right, that's always going to be my output variable. My output variable, y, is the amount in dollars. Right? So that's the amount in dollars. Right? It's supposed to be a dollar sign. So the amount in dollars is my dependent variable. For part B, how much is in your savings account after 8 weeks? I take my original equation. We know that the independent variable, my x value represents the number of weeks. So y is equal to 10 times, replace x with 8, plus 25. Y is equal to 80 plus 25. So y is equal to 125. And that 125 represents what? The amount in dollars. All right, $125. Okay? Next example. All right. It says you can use tables and graphs to represent equations into variables. The table and graph below represent the equation y is equal to a number plus 2. Here's my table. My independent variable are my x values here. My dependent variable, those are my y values here. These are my inputs. Y values are my outputs. My ordered pair, I replace x with 1. 1 plus 2 gives me an output of 3. So 1 comma 3 is my ordered pair. When my input is 1, my output is 3. If I use an input of 2, which means I replace x with 2, well, what is 2 plus 2? 2 plus 2 is 4. So when my input is 2, my output is 4, which gives me an ordered pair of 2 comma 4. If I use an input of 3, that means I replace x with 3. What is 3 plus 2? Well, 3 plus 2 is 5. So when my input is 3, my output here is 5. Right? So I get ordered pairs, and I graph my ordered pairs on a coordinate plane. And we're going to do a couple of those. All right? Next slide. Okay, you can read through this, right? But it's the same idea. Okay? You're given a word problem, right? You write the equation from the word problem. You use the equation in two variables here to create your table. From the table, you make your ordered pairs, and then you're going to graph your ordered pairs this way, right? So let's do an example on our own. Costs $25 to rent a kayak, plus $8 for each hour. Write and graph an equation in two variables that represents the total cost of renting the kayak. Okay, well, the total cost is going to be equal to $25, right, plus $8 for each hour. Okay, my two variables are my cost and the number of hours. The number of hours would be my independent variable. Right? That is my input value. The cost of renting the kayak will be my dependent variable. That is my output information. Okay, once I have my equation, then I can make a table. Right? And from my table, I'm going to make ordered pairs. So I'm going to make a table. Oops. Going to make a table real quick. So let's start with my input is H. I have 25 plus 8 times H. Make a table, has a few columns. Your output then is C, and then you have your ordered pair column. Right, that is X comma Y. All right. We'll find the cost of renting the kayak for 1 hour, 2 hours, 3 hours, and 4 hours. Which means my H, my input, my independent variable, I'm going to replace H with 1. So this is going to be 25 plus 8 times 1. This is going to be 25 plus 8 times 2 because I'm replacing H with 2. This is going to be 25 plus 8 times 3. This is 25 plus 8 times 4. So when we have a situation like this where we're given a word problem, first we write the equation in two variables representing this situation. And usually you can get all that information in the first sentence. Once we write the equation, we make a table. I like for my students to make a table with 4 columns. Your first column are your inputs. Your second column I call the evaluation column, where we are replacing the variable with the values. Third column is your output. 8 times 1 is 8. What is 25 plus 8? Well, 25 plus 8 is 33. What's my ordered pair? My ordered pair then is 1 comma 33. 2 times 8 is 16. Well, what's 16 plus 25? That is 41. Notice we have to use the order of operations here. I do the multiplication first. 8 times 2 is 16. Then I add the 25. So my ordered pair is 2 comma 41. My next evaluation, 8 times 3 is 24. What's 25 plus 24? That is 49. Your ordered pair is 3 comma 49. And then finally, 8 times 4 is 32. Well, what's 32 plus 45? That should be 57. So 4 comma 57 would be your ordered pairs. All right. So now, when we graph this information along the horizontal axis, that is always going to be our input values go along the horizontal axis. And along the horizontal axis, our input values represent what? Hours. And we have 1, 2, 3, and 4. So we label it hours. And I'm going to label 1 hour, 2 hours, 3 hours, 4 hours. It's very important that your intervals are precise here. So I'm using 2 spaces for 1 hour, 2 spaces for 2 hours, which means each interval is 30 minutes. 30 minutes, 1 hour. 1 hour, 30 minutes, 2 hours. 2 hours, 30 minutes, 3 hours. 3 hours, 30 minutes, 4 hours, right? We have to make sure those intervals are correct. And if you want to keep going, you can go to 5 and so on. Your outputs, right? We have to label our vertical axis as well. The vertical axis will always be your outputs. The outputs represent cost. So we're going to label that. Cost in dollars. Right, we want to label that, the cost in dollars. And the cost in dollars, we have to go all the way up to, looks like 57, so about up to 60. So let's see what we have here. If I could do 5, 10, 15, 20, 25, I could do that. So I'm going to do 10, 20, 30, 40, 50, 60. You have to be careful, once again, that your intervals are precise here. So I'm using intervals of what? 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. You have to use intervals that are large enough for you to be able to fit all your data points. All right, now I'm ready to graph. My first data point is 1 comma 33. So I go over to 1, I go up to about 33. Well, here's 30, here's 35, so 33 is going to be about here. That's where 1 comma 33 would be. My next ordered pair is 2 comma 41. All right, so I go over to 2. I go over to 2 on the x-axis. I go up to 41. 41 is going to be just above 40, 2 comma 41. Let me zoom this out a little bit to make it a little bit easier to see. View, zoom, and we're going to zoom to, let's say, 100. That's a little better so we can see the whole picture. Okay. Next ordered pair is going to be 3 comma 49. So I go over to 3. I go up to 49. 49 is going to be just below 50. Now, one of the things you should notice that all your points should be in a straight line. So it's called a linear function. You're going to learn more about that a little bit later this year and next year and the year after that. But all of your data points should be in a straight line. All right, and then finally we have 4 and 57. So I go over to 4, up to 57. 57 is going to be just below 60. All right, but you want to cheat a little bit, make sure everything's in a nice straight line, and then you take your ruler, all right, and you connect your points. All right, and I like to extend that if we can. I like for us to draw arrows at the end of our line. So we draw an arrow to show that that relationship's going to go on forever. All right. Okay, so once again, let's review that. We start with the word problem. From the word problem, we write an equation that represents the situation. $25 to rent a kayak plus $8 for each hour. So the cost is equal to $25 plus 8 each. We take this equation and we use that in our table. We have our inputs. Part of our equation comes first. The output part of our equation is our third column. The last column is our ordered pairs, and we use those ordered pairs to graph. Okay, let's go on. It says you can model many rate problems using the distance formula. D is equal to R times T, where D is the distance traveled, R is the speed, T is the time. When you're given a speed, you can use the formula to write an equation in two variables that represents the situation. Okay? You're given a situation. A train averages 40 miles per hour between two cities, which means 1 hour, the train would travel 40 miles. 2 hours, the train would travel 80 miles. 4 hours, the train would travel 160 miles. 6 hours, the train would travel 240 miles. All right, that would be a ratio table. Or you can use the values in that ratio table as ordered pairs. 1, 40. 2, 80, 4, 160, and 6, 240, and we use those ordered pairs to graph. All right, let's try an example. Okay. It says, on your own, the train averages 50 miles per hour. Use a graph to show the relationship between the time and the distance traveled. The train averages 50 miles per every hour. So the distance is equal to R times T. Okay, and the rate is 50 miles per hour. So the distance is equal to 50 times T. That would be the equation we would use there. And then we create a data table. So T is our input. We have 50 times T. Output is going to be D, and the ordered pair X, Y. Probably should give myself a little bit more room, but you'll get the idea. We'll do it for 1 hour, 2 hours, 3 hours. We'll make it quick. So if it goes 50 miles an hour for 1 hour, what's the distance? 50 miles. If the train travels 50 miles an hour for 2 hours, how far will it travel? 50 times 2 is 100. If the train travels 50 miles an hour for 3 hours, it's 150. So your ordered pairs are 1, 50. We have 2, 100. And then we have 3, 150. All right. Remember, along the horizontal axis, those are our input values. And what does the T represent? The T represents time in what? Hours. So we label time, and those in hours. H-O-U-R-S. Time in hours. Well, what's the output? The output is distance. And those are in miles. All right, we always have to label our axes. Our horizontal axis are always the input values. The vertical axis will always be your output values. Okay? Or if you want to think of it as your independent variable along the horizontal axis, your dependent variable along the vertical axis. And then we need some intervals. We can go 1, 2, and 3 for hours. And we have to go up to 150 miles. Let's see, 10, 20, 30, 40, 50. I think we can reach 150 by using intervals of 10, so we'll do that. 10, let's say 20, 30, 40, 50, 60, 70, 80, 90, 100. That's 120. And 140, 150 is going to be right above that. So we have 1, comma 50 is our first ordered pair. 2, comma 100 is our second ordered pair. And 3, comma 150, is our third ordered pair. Remember, right, your point should go in a straight path. If you can't connect those points, using a straight line, you did something wrong. All right? And that's it. All right? I believe that's the last part of the lesson, and hopefully that's going to be helpful. All right? You guys are going to work on the exercises and do your best with it.